Okay, today we are going to discuss inclusion and exclusion principle, right? So the inclusion and exclusion principle means that is related to the equation of number of A union B, right? If you write an equation between A union B to find out the elements of A union B, that is we can tell as a inclusion exclusion principle, right? So previously we know number of elements A union B is equal to number of A plus number of B when the situation A and B are disjoint sets, right? If A and B are disjoint set, this is the equation we know, right? But this is actually not the equation, right? Not only for disjoint set, even the sets A and B are not disjoint, we have an equation to find out the number of elements in A union B, right? Now, let's say we have two sets A and B, right? They are not disjoints, right? Now, in this situation, they are not disjoint sets, right? So if they are disjoint sets, we know the equation, right? Even A and B are not a disjoint sets, we can find out the A union B. So the equation says number of elements in A plus number of elements in B subtract number of elements in A intersection B, right? This equation we can say inclusion exclusion principle, right? If you find out the number of A union B in the situation where they are not disjoint sets, that is we call inclusion exclusion principle. So if I ask you what you write the inclusion exclusion principles, you need to write this equation, right? So inclusion exclusion principle means if there are two sets A and B, they are not disjoint sets. So at the situation, number of elements in A union B is equal to number of elements in A plus number of elements in B my subtract number of elements in A intersection B, right? So some situation while you are doing some calculation or something, sometime you need to find out the number of elements in A intersection B, right? So at that situation, you can change the subject from the inclusion exclusion principle, right? So if you change the subject as this element, now what will happen? So now what will happen? Number of in this situation you need to find out number of elements of A plus number of elements in B subtract number of elements in A union B, right? So whatever you want, you can change the subjects and calculate from this inclusion exclusion principle, right? Any questions? So just remember the equation. Even you don't need to remember, right? If you don't remember the equation, maybe the easiest way, just plot the Venn diagram, right? So if you draw the Venn diagram, this is A, just imagine this is B, right? This is union. So only you need to remember number of elements in A union B. That is the inclusion exclusion principle. So A union B means you need to think about this entire area, right? You need to think about this colored area as a elements of number of A union B, right? So at that time, what will happen? Just you can find out number of elements in A. So number of elements in A means, just think about number of elements in A means, so number of elements in A means this area, right? Number of elements in A means this area, right? Number of elements in B means, just imagine here, right? So this area, right? So it means the intersection area, right? The intersection area is duplicating, right? So if you look at here, So this area, the intersection area is duplicated twice, right? So that's why we, let's say number of A plus number of B means this, while you are adding number of A, it will cover all this area. Number of B means it will cover all this area. So at that time, this intersection area is duplicating two times, right? So we need only one time. So that's why we are subtracting number of A intersection B one time, right? This is the equation you need to remember, right? Yeah, someone asked about the next topic. Next topic may be probability, and then we will discuss relations and functions. Then we will discuss integration and differentiation integrations, right? I will inform what is the next topic by next class, right? Maybe we will discuss relations and functions, or sometimes we will discuss sorry, yeah, probability, right? I will inform by next class, right? So now you know how to write the inclusion exclusion principle for two sets, right? Similarly, if you have three sets, then you can write the inclusion exclusion principle, right? If you have three sets, also you can write the inclusion exclusion principle. Just imagine you have three sets A, B, and C. Then if you write an equation for number of elements in A union B union C, that is called inclusion exclusion principle for three sets, right? If you write an equation for uh, A union B union C, number of elements in A union B union C for three sets, we can say that is a inclusion exclusion principles for three sets, right? So in the previous example, number of A, number of B, then you are adding, right? Adding these two things. That is, we can call inclusion, right? Include. Here, you exclude the intersection, right? Number of elements in A intersection B, you subtract, right? That is a exclusion, right? So that is we call inclusion exclusion principles, right? Okay, now I will write the equation and explain, right? So if we have three sets A, B, C, then the number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C minus subtract number of elements in A intersection B minus number of elements number of elements in B intersection C minus number of elements in C intersection A plus number of elements in A intersection B intersection C, right? This is the equation for uh, three sets, right? Likewise, whatever the number of sets, you can find out the inclusion exclusion principles, right? To understand this equation, right, easiest way, you can draw the uh, three sets, the Venn diagram, right? I will draw the three set Venn diagram. Give me a minute. Sorry for that. Okay, then just imagine this is A, this is B, this is C, right? So number of A means what will happen? Number of A means you are considering this area, right? Number of B means this area. Number of B means this area, right? Similarly, number of C, number of C means this area. So once you notice here, right? If you add number of A plus number of B plus number of C, what will happen? You are duplicating this area. You are duplicating this area twice, right? Similarly, you are duplicating this area 2 times, right? Similarly, you are duplicating this area 2 times, right? So, so now what will happen? This is 2 times, this is 2 times, this is 2 times, this is 2 times, right? Now we have subtracts. So number of A intersection B means we are subtracting this one. Also, we are subtracting this one. We are subtracting this one. Now what will happen? Only you are remaining this area, this area, this area, right? So already you have 2 times. Each intersection area you have 2 times, right? Then you subtract 1 time for each. Then what will happen? Sorry. Now what will happen if you subtract the intersection of these three? So every this portion will consider, right? But you are not considering the three intersection area, then we can add this one, right? So number of A plus number of B plus number of C, subtract the intersection, again addition of the intersection of these three area, number of A union B union C. This is one way. Another way, maybe you can define some elements for A. A is a set with some elements, B is a set with some elements, C is a set with some elements. Then you will find out what is A, B, C. Then you can easily remember the equation, right? Just remember this equation. But sometimes you need to use this equation to do the calculations, right? So this is we can call inclusion exclusion principle, right? Now they are asking a question, right? So just read this question, right? Yeah, example 1.8. So they are saying, right, now we need to apply this inclusion exclusion principle to answer this question, right? If you look at here, they are mentioning suppose a list A contains 30 students in mathematics class, right? And a list B contains 35 students in English class. So here they are mentioning two sets, max class and English class, right? So now, uh, now how you can write as list A, right? So number of A is what? How many? Tell me number of A is what? Number of A means list of students. Someone asked a question, right? Wait. Yeah, they are asking why we are adding number of A plus number of B. Yeah, in the three sets, right? So I will explain before this one, right? Just imagine you have three sets, right? Just imagine you have three sets A, B, C, right? Okay, I will explain different way, then you can understand, right? So this is A, this is B, this is C, right? Then I am giving letters for each area. This is A1, this is A2, this is A3, this is A4, this is A5, this is A6, this is A7, right? Now imagine, right? The equation says number of A union B union C is equal to number of A plus number of B plus number of C minus number of A intersection B minus number of B intersection C minus number of C intersection A plus number of A intersection B intersection C, right? This is the equation, right? Now just imagine, right? Uh, okay, just think about this one, right? So number of A plus number of B plus number of C. Now tell me, number of A means what? So number of A means A1 plus A4 plus A5 plus A7, right? So number of B is equal to what? Tell me. A2, A4, A6, A7, right? Number of C is equal to A3, A5, A6, A7, right? Now we need number of A union B union C. It is what? A union B union C means what? A1, A2, A3, A4, A5, A6, A7, right? This is, sorry, A7. This is A union B union C, right? The sum of these 7 elements, right? Now, just imagine we are consider number of A plus number of B plus number of C, right? It means it contain all these elements, right? Sorry, just this is C, right? Just imagine it contain these elements, right? Now, if you look at here, it occurs A1 one time, right? A2 one time, right? A3 is one time, right? Now, if you look at here, A4 occurs 2 times, right? A6 occurs 2 times, right? Similarly, A5 occurs 2 times, right? Similarly, uh, yeah, A7 occurs 2 times, right? Am I correct?
A7 3 times.
Yeah, sorry. Is it okay? 1, 2, 3, 4, 1, 2. Yeah, it's correct. Yeah. So A time occurs 3 times. Yeah, very good. Now just imagine, right? Why I am subtracting these A intersection B. Now tell me, what do you mean by A intersection B? A intersection B means it contains what? A4 plus A7, right? So just I delete this one, right? Now just look at here. These three we already get it, right? So now just look at here. I subtract A intersection B. Why I subtract A intersection B? Just imagine I have 2 times A4, right? But I need only 1 time A4, right? So I need to subtract 1 A4, right? So now 1 A4 is correct. Now I cannot subtract A1 separately. Now what I'm doing here, I subtract these two elements together. Now if I subtract these two elements together means what? That is the subtraction of A intersection B, right? Similarly, I need only one A5. So that A5 is here, right? Now I subtract, better, yeah, sorry. This is A5. So now I use this A5, only one A5. Now I can remove this A5 and this A7 together. That is A5 and A7 together. I can say that is the subtraction of intersection A intersection C. Similarly, I need only one A6. Now I keep this one. Just I can subtract this one, right? So this A6 plus A7 is subtraction of A intersection, sorry, B intersection C, right? Now, what is the problem here? I have all the six part, right? But I need only A7, right? But I have only three A7s. I subtract all three A7 portions. Now, that's why I need again add one portion of A7, right? So A7 means that is a intersection of A intersection B intersection C. Did you clear now? Did you understand? Did you get my point? Why I am adding A intersection B intersection C? So we already know A union B union C means all the colored area, right? So it means A1 to A7, right? Once you add number of A plus number of B plus number of C, these are the extra elements, right? So I need to remove the extra elements, then I can apply these. Okay. Yeah, now we will look at the question, right? Okay, now we will look at the question. Yeah, in this question, there are two sets, right? Set A for mathematics, set B for English class, right? They are mentioned in a set A, there are 30 students. So 30 students means number of A is equal to 30, right? Similarly, they are saying in set B, uh, set B, in list B, 35 students in English class, right? Number of B is equal to 35, right? Then they are saying, right? Suppose there are 20 names in both lists. What do you mean by 20 names in both lists? Is it intersection or union? Tell me. So this is they are explaining throughout the sentence, right? There are 20 students name in both lists. Both list means that is union or intersection?
Intersection.
Intersection, right? So you know these three things. Now they are asking some questions, right? So what is the first question? They are asking only on list A. It means what? Only on list A means what? They are asking number of only on A means A minus B, right? This is we can say only on A. So how you can find out A minus B? Tell me. We already discussed an equation. Number of A minus number of A intersection B. Don't you remember this equation? If you don't remember the equation, just draw a Venn diagram and look at here, right? So this is set A, this is set B. We know they are asking only on list A. Only on list A means what? This colored area, right? This colored area we need to find out, right? This colored area we need to find, right? This is only on A. So that means A minus B. So A minus B means we know number of A, we need to subtract this area, right? So this is the equation. So if you put on this equation, number of A we know 30 minus number of A intersection B we already know 20, right? So the answer is 10. Similarly, the B, they are asking only on list B. So number of only on list B means B minus B difference A. So similarly here, number of B minus number of A intersection B, right? So number of B is equal to 35 minus A intersection B is 20. So that is 15, right? That is the answer for second part. C part, what, tell me, first thing you need to understand what is the question on a list A or B. A or B means what is the question they are asking? Number of A or B. A union B. A or B means union B. So we already know the inclusion exclusion principle. What is the equation for inclusion exclusion principle? Number of A plus number of B subtract number of A intersection B. Now tell me, number of A is equal to 35. Sorry, number of A is equal to 30. Number of B is equal to 35 minus 20. So 65 minus 20. What is that? 45 is the answer, right? So 45 is the answer. The last question on exactly one list. What do you mean by on exactly one list? Tell me. What do you mean by on exactly on one list? Anyone? Tell me. What do you mean by only on one list? There are names in list A or B, right? There is nothing common, right? They are asking the names of the students who is only taking mathematics or only taking the English, right? Only on list. One list means what? You need to find out. This is also we already discussed. This area plus this area plus this area plus this area. So now tell me what is this? We already know a equation for this one as well, right? So we discuss symmetric difference. Do you remember? A symmetric difference B. So that is they are asking here, right? Number of elements in A symmetric B. So what is the equation? Number of A minus B union number of B minus A, right? So now tell me, already we know A minus B. What is that? A minus B is 10 union. So union means we need to add plus, right? So if it is a union means you need to add both, right? So 10 plus B minus A 15 altogether 25, right? So 25 is the answer for last part, right? So this is an example question, right? Okay. Now we will move for the next heading. Okay, the next topic, classes of sets, power sets, and partitions. These are the three things we are planning to discuss as a next. We will discuss one by one. First, we will look at what is class of sets, right? Class of set means we already discussed. Let's say you have a set. Let's say you have a set A. It contain elements 1, 2, 3, 4, 5, right? Okay, just imagine we have only three elements, right? Class of set means you have a set called A. That set contains three elements, 1, 2, 3. Can someone tell me how many subsets you can write for this one? How many? What is the number of subsets for A? Number of subsets. What is the equation? 2 to the power n. So for n here, three elements. So 2 to the power 3, you can write 8 subset for this one, right? So if you write all the 8 subsets, can you write all the 8 subsets? So 1 is a subset, right? 2 is another subset. 3 is another subset. 1 and 2 is another subset. 1 and 3 is another subset. 2 and 3 is another subset. So altogether 6. 1, 2, 3 is another subset. Empty set is another subset. Altogether 8 subset. 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets, right? So class of sets means you are creating some subsets by using the subsets. It's confusing, right? Let's say these are the 8 subsets of the set A, right? For the set A, you can write 8 subsets, right? If you define another set by using some of these elements, some of these components, we can say that is a class of set, right? Just imagine now you are writing a set, right? Now you are defining a set. Let's say now we are defining a set B, right? B is a set of X such that X contains any three elements, any two elements from set A. Did you get my point? Now you are creating another set B. Each you need to create elements of set B. It contains any two elements from set A, right? So it means if you define this B, right, any two elements from set A. So here in set A, we have three elements. Now you need to create elements of set B that contain any any two elements. So you can create one set as a 1 and 2 as a one element of set B. Similarly, 1 and 3 as a another element of B. 2 and 3 is another element of B, right? This is set B, right? This is called, this class, this B is called class of set, right? Normally we can say set of sets, but it's confusing. To overcome this confusion, we can say class of sets. So normally this is set of sets, right? We are creating a set B with the help of, by using the elements of set A. So we can say set of sets. To, that is confusing. To overcome the confusion, we can say class of sets or collection of sets. These are the two names, class of sets or collection of sets. So class of sets or collection of set means you are creating elements of an existing set by using some conditions, right? Now, you maybe sometimes you are creating another set C on such that X is an element, X contains any two elements. Among these two elements, one element must be 1. One element must be 1, right? So can you write the set? One element must be 1 means, so among the all the subsets, first you need to find out what are the two element sets. Among these two element set, which elements consider as a only one element is a 1, right? So these two sets. So now we can say 1, 2 is and 1, 3. These are the set of sets, class of sets, the class of set in C. Now, if you look at B and C, C is a subset of B, right? C is a subset of B. C is a subset of B. We can write C is a subset of B, right? This is the concept behind class of sets, right? So class of sets means already you have a set, right? From that set, you are creating some subset that is class of sets, right? So class of set means you have a given set. For that set, we know there are n 2 to the power n number of subsets. Among these 2 to the power n number of subsets, we are creating some other classes, other sets. Those sets we can call set of sets. That is, we can call as a class of sets or collection of sets, right? Yeah, someone says confusing. Confusing. Yeah, I will explain again. I will explain with the given example as well, right? So class of set means, let's say, first you need to think you have a set, right? So set means that set contain n number of elements, right? Did you get my point? Class of set means first you have a set, right? Just imagine. Okay, I will explain with this given example, right? Class of set means, set means, you know, right? Set means, let's say we will take S is equal to, S is a set. The elements of S is 1, 2, 3, and 4, right? There are 4 elements in set S, right? Now tell me how many subsets we can write for S. Tell me 2 to the power 4. Then you can write 16 subsets, right? For this 16 subsets, for the set S, you can write 16 subsets, right? I think you clear right this one, right? Just imagine you have a set. If any set, they have n number of elements, right? Let's say in this set S, you have only 4 elements. So by using these 4 elements, you can create 16 subsets, right? Now, if you're creating some other sets by using the subsets of this S, we can say that is a class of sets. Now, if you understand, you have a set. For that set, you can write n number of 2 to the power n number of subsets. You will pick some subset from, you will pick some subsets of this particular set. Yes. If you create another set, that set we can call class of set. Did you get my point? So you have a set, let's say you have a set A, right? That set contains 4 elements, 1, 2, 3, 4, right? Now we know if you have a set with 4 elements, you can create 16 subsets, right? So can you write 16 subsets? 1 is a subset, 2 is a subset. It means 1 element sets, 3 is a subset, 4 is a subset, then 1, 2 is a subset, 1, 3 is another subset, 1, 4 is another subset, 2, 3 is a subset, 2, 4 is a subset, 3, 4 is a subset, right? Altogether 16. So 4, 6, 8, 10 is coming, right? Then with 3 elements, what are they? 1, 2, 3 is a subset. Sorry, right here. 1, 2, 3 is a subset. 1, 2, 4 is a subset. Then 1, 2, 3. 1, 2, 4 is a subset. Then 1, 3, 4 is a subset. Then 2, 3, 4 is a subset, right? So altogether 14. Then 1, 2, 3, 4 is a subset. Then the empty set is a subset, right? So if you have a set A with 4 elements, so you can create 16 subsets, right? Now, if you create any set by picking some of these subsets, if you create any subset by picking one or more than one subsets, we can say that set as a class of set or collection of sets, right? Did you get my point? So among these all the possible subsets, if you create another set, let's say now you are creating another set. Let's say now you are creating another set A1, right? It means it's a now you are creating a set A1, right? The definition of A1, they are telling sets with 3 elements of A, right? Now you need to define a set A1, right? For each element on A1, they have 3 elements of A, right? So in set A, there are 4 elements, no? So you need to pick any 3 elements from A, then you can create elements for A1. Now, can you tell me what are the elements for A1 you can generate? For A1, they are giving a condition, only A1, each element contain 3 elements from A, right? Maybe for the confusion, I'm putting a square bracket here rather than curly braces. I'm putting a square bracket here, right? Can you write all the elements of A1 now based on this condition? This is the condition they are mentioning, right? For set A1, you need to create element with 3 elements of A. So then one element is 1, 2, 3 is one element, right? It means among these 1, 2, 3, 4, you are considering only 3 elements, 1, 2, 3. So this is one element of A1. Similarly, 1, 2, 4, right? You omit 3 and you are taking 1, 2, 4. This is another element, second element. Then you are considering 1, 3, 4 as a third element. The last one, 2, 3, 4 is the fourth element. You cannot create more than these 4 elements of A1, right? Maybe if you are creating with maybe different combination, but it contains all these 3 elements, right? So this is A1. Similarly, there is another set A2. They are telling, right? You need to create a set with 3 elements of A, but they are giving a condition. One element must be 4, right? One element among these 3 elements, one element must be 4, right? Now, can you write the set A2? Can you try this one and tell me? In this question, in the A2, they are giving in A2, right? What they are telling, you need to create a set with 3 elements of A. Among these 3 elements, one element must be 4, right? Then how you can write this? So, you know, A has 4 elements, right? 1, 2, 3, 4, right? So just I write again. A has 4 elements. 1, 2, 3, 4, right? They are telling you need to create 3 element sets, right? But one element must be 4, right? So 1, 2, 3, we cannot take 1, 2, 3, right? Because there is no 4 here, right? So 1, 2, 3, we cannot take. So this one we cannot take. If you look at 1, 2, 4, that must be come, right? 1, 2, 4. 1, 2, 4, it must be come, right? If you look at 1, 3, 4, it is also come 1, 3, 4 because 4 is there, right? If you look at 2, 3, 4, it is also come 4 is exists, right? So these are the 3 elements of A2. Now, if you think about A1 and A2, right? A2 is a subset of A1, right? This is explicit truth, right? So this is the theory of class of set. Class of set means already we are giving a set, right, with n number of elements. So for that set n, for the let's say we have a set A, for that set contain x number of elements. So 2 to the power x number of subsets we can write for the set. Among the 2 to the power x number of subsets, if you define some sets, we can call those sets a class of sets or collection of sets, right? Sorry. Yeah. So this is explained by these up to these, right? So class of set means for the given set, you can write a subset n 2 to the power n number of subset. Among these 2 to the power n number of subset, you are picking some subset, and if you create a new set, that is called class of set or collection of sets, right? Power set means you can write a set that contain all the subsets, right? So in the previous example, just look at here for set A, right? For the set A, right? We have 4 elements. So 2 to the power 4 number of subsets. So 16 subsets. So this 16 subset, we can say power sets, right? So power set. So power sets means you need to create a set which contains all the subsets as a set, right? Now I'm telling X as a set, right? Which contain uh, vowel letters in English, right? Right? Okay, I'm asking you, write the power set. We can write power set by using P of X, right? P of X means that is a power set, right? So I'm asking you, could you please write the power set? How to write the power set? Can you try this one? If you understand what I'm saying, you can write P of X. P of X means that is a power set of X. So first you need to find out the elements of X. So what are the elements of X? A, E, I, O, U, right? These are the elements of X. Now, how you can find out the P of X? So P of X means that is a power set, right? So theory says if it is a power set means you need to write all the possible subsets. So if you have 5 elements, so you have 2 to the power 5, right? 2 to the power 5 means 32 subsets, right? So if you create a set P of X with 32 elements, we can say that is a power set of X, right? So power set of X means A, right? E. Just try yourself, right? One element set. Then we need to move for the 2 element set. AE, AI, AO, AU, right? 1, 2, 3, 4. AE, AI, AO, AU. Then I need to take. So here 5, here 4, 9, right? 9 coming. Then EI, EO, right? EU, right? So 12 altogether, 12 is coming, right? Then IO, IU, so 14 coming, right? Then OU, altogether 15, right? Altogether 15. Okay, yeah, you can try, right? Just I give 5 minutes. You can write all the possible subsets, right? The power sets. So if you create a set with all the subsets, we can say that is a power set, right? So you need to write a set with all the 32 elements. We can say that is a power set, right? So power sets we can denote it by P of X, right? P of A means that is a power set of A, right? So you need to write all the subsets of P, sorry, all the subset of A as a set. Then we can say A as P of A as a power set of A, right? Any questions? Any questions? Okay, if you don't have any questions, now we will move for the partitions, right? So partitions means, give me a minute. Okay, yeah. So partitions means, just imagine you have a set, right? For that set, you are splitting n number of partitions, right? This is, we can call partition, right? There is a set S. We are splitting that set into n number of partitions. Uh, to define the partitions, there are two things you need to check, right? So if you take one element A, that element belongs to any one of your partitions, right? Maybe just imagine here A1, A2, A3, A4, A5, A6, A7 up to AN, right? The element A belongs to any one of AI, maybe that elements belongs to one of your partitions, right? That is the first thing you need to consider. Second thing, each partitions, they are mutually disjoint, right? Mutually disjoints means if you look at any two partitions, they are disjoint, right? That is, we can say as a mutually disjoint, right? So if you take any two partitions from your set, they are disjoint. It means they don't have any elements. If you take A1 and A2, they are, their intersection is empty. This is the internal meaning, right? Mutually disjoint means there is no common elements between two partitions. These are the two concepts you need to remember while you are doing the partitions, right? So if you are partition something, you need to check these two conditions, right? If let's say, just imagine you have a set S, right? Right? Let's say set S. So partition S1, they are telling 1, 2, 3, right? Partition S2, they are telling 3, 4, 5. What do you think about S1 and S2? Is there partitions? Tell me, is there partitions? S1 and S2? S1 and S2 partitions or not? So these are the two set of rules you need to check. What do you think based on this condition? They are not partitions, right? Why? 3 is the common elements for S1 and S2, right? It means the S1 intersection S2 is not empty, right? So S1 and S2 are not partitions, right? Okay, now think about S3. Okay, now this is one scenario, right? Now I am writing S2, right? Okay, here 1, 2, 3, here 4, 5, 6, 7. What do you think now? So you have a set S. That set has two partition, S1 and S2. Right now, tell me, S1 and S2 are partitions or not? Hmm?
Partition.
What do you think? This is not partition, right? There are some new elements. Did you notice this one? 7 is a one element, right? 6 and 7 are not elements in the S, right? So let's say, yeah, I will write this way. So S1 and S2 is not partition. This is one scenario, right? Now just look at here. Yeah. Okay, what do you think now? S have 5 elements, but you have only 2 partitions, right? But the important thing, all the elements belong to at least one of the partition, right? But not here. The 5 is not belongs to any partition, right? If you have more number of partition, then check all the elements, right? So you need to check these two conditions. What is the first condition? If you consider one element, it must be a element of any partition one, right? But any of the partition, it takes responsibility for that element, right? If you look at an element of that, let's say you have one element, you need to check that element belong to one of your partitions or not. If that elements not belongs to one of the partitions, we can say that is not a proper partitions, right? Also, they are mutually disjoint, right? These are the two conditions you need to check the partitions, right? Now, just look at here. They are giving an example, right? Just consider there is a set S, right? There is a set S with 9 elements, 1 to 9, right? It contain 1 to 9. Now tell me, they are giving uh, some sets, yeah, this one is a partition, this one is a partition, this one is a partition. Now, what do you think about the first one? Is it a partition or not? Just look at the first one. They have 3 partitions, right? So what do you think about the first one? Is it a partitions or does not belongs to, does not consider as a partition? First one, someone says yes. Someone says no. What do you think? What is the reason? I need the reason why you are saying there is a partition, why you are saying it is not a partition, right? That is what I need. So if you look at here, the set S contain 9 elements, 1 to 9, right? So you need to check all the 9 elements are belongs to one of the partition. 1 is there, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, 8 is there, 9 is there. 7 is missing, right? So 7 is not belongs to any partition. So we cannot say it is not a properly partition, right? How about the second one? Second one, 1, 2, 3, 4, 5, 5. So 5 happened 2 times, right? It means 2 partition contains the same elements, but it's break the rules. What is the second rule? Mutually disjoint. It means their intersection is empty. But here, 2 partition contains the same element. So because of that, we cannot say this is a proper partition, right? How about the third one? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a proper partition, right? All the 9 elements of set S belongs to 3 partitions, right? So there is no intersection, common elements. There is no element missing. So this is a proper partition, right? Any questions? Yeah, why first one is not a partition? I already told you, right? If you have a set S, right? If you write all 3, if you write the partitions, right? All the elements of set S contain one of the partition, right? If you look at 1, it is an element of first partition, right? So we can say this is a partition P1, this is partition P2, this is partition P3. Just imagine, right? If you look at this way, so 1 elements of P1, right? 2 is an element of P2, partition 2. 3 is an element of partition 1, right? 4 is an element of partition 3, right? 5 is an element of partition 1, right? 6 is an element of partition 2. How about 7? 7 is an element of which partition? There is nothing, right? So 7 is not assigned for any partition. So we cannot say this is a not proper partitions, right? So if you are properly partition the set S, all the elements belong to at least one of the partition, right? But here 7 is not assigned for any partition. So because of that, we can say this is not properly partitioned, right? Yeah, partition is a one set, right? One of sets. Yeah. Okay. Now we will move for the next one, right? Generalized set operations, right? So generalized set operations means uh, we are normally using the union and intersection, right? To generalize the set operations, right? Okay. Normally we are considering 1 or 2 or 3 sets, right? For A union, B union, C. We cannot limit to these number of, right? Maybe you have maybe you have finite number of sets. Maybe you have one, maybe you have sets A1, A2, A3 until AX. Just imagine, or AM, right? AM. So how many sets here we have? Tell me how many sets? M number of sets are there, right? M number of sets here, right? So it's very difficult. Let's say some situation, we need to write the union of this one. A1 union, A2 union, A3 union, dot, 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 union of AM, right? This is a very long one, right? So generalized operation means rather than we are writing this way, we are generalize the symbol by using U, right? Here, I am writing I is equal to 1, starting position 1. From here, the last set M, right? If I write this way, you need to understand this is equal to, okay, I is equal to 1 to M, then AI, right? So if I write this way, you need to understand starting from A1, sorry, A1 union, A2 union, A3 union until AM union, right? So this is the short form of unions of M number of classes, right? Similarly, if it is an intersection, I am putting this intersection symbol, I is equal to 1 to the last set M. AI means it is indicated by A1 intersection, A2 intersection, A3 intersection, A4 intersection until AM, right? This is the shortened form of the sets we need to denote in some situation, right? Now tell me, right? Okay, now can you guess this one? Union of I is equal to 5 to 10.
Yeah.
Hmm. X.
What
I.
is the meaning AI?
So So AI means that is a set, right? A is a set, A1 is a set. So AI means the common symbol, common form, right? So let's imagine you have a set A1. A1 is a one set, A2 is another set, A3 is another set, A4 is another set. Likewise, you have AN, N number of sets, N sets you have, right? So it's difficult to write the union or intersection operation for among these, right? Let's imagine you have, this is 100, right? You have 100 sets, A1 to A100, right? So normally, whenever you write, you need to write the union of, let's say some equation, you need A1 union, A2 union, A3 union. So it's take time, right, to write until A100, right? To overcome these, we can write easiest way, right? Union of I is equal to 1 to 100 AI, right? Then whatever the set conditions you can write, right? That's the shortest form, right? Can you tell me what are the elements come for this one? I write this one right now. Can you write this one? I is equal to 5 to 10 xi. So what are the sets consider here? X5 is a one set, X6 as another set, X6, X7 is another set. So not this one, right? Here, what are the sets? Sets are there. X5, one set. X6, another set. X7, another set. X8, X9, and X10 are the sets, right? Similarly, intersection of I is equal to 10 to 100 means AI. So here, A10 is a one set, A11 is another set, A12, A13, A14. They are the sets. Among all these sets, we have intersection, right? A10 is a one set, A11 is another set, A12 is another set, A13 is another set. Likewise, until it will goes. This is a short form of the sets we can generalize set operations, right? The last thing, mathematical inductions, right? Okay, while this is very basic, right? I think you know that what is induction, right? Mathematical induction you learn in your O levels or grade 10, right? Just imagine, right? We use induction, right? Let's say you have a equation called sum of first n numbers, right? Sum of first n numbers. So maybe you learn these things, right? So sum of n 1, 2, 3, 4 until n is equal to n into n plus 1 by 2, right? This is the sum of n numbers, right? So this is a common equation, right? 1 plus 2 plus 3 plus 4 plus n is equal to n into n plus 1 by 2, right? To prove this one, right? So to prove this one, we take if n is if n is equal to 1, then we can take left hand side is what? 1, right? If you take right hand side is uh, n, so n is 1 means right hand side 1 into 1 plus 1 divided by 2, right? So it means 1 into 2 divided by 2, 2 and 2 cut. So this is 1, right? So left LHS is right, RHS, right? Right hand side. So this is true for 1, right? Then we take if n is then we take if n is equal to k. Let's assume, so this is we already learned, right? Induction, mathematical inductions, right? N, assume if n is equal to k, then it's true, right? It's true means what? So if let's assume if n is equal to k, then 1 plus 2 plus 3 plus k is equal to k into k plus 1 by 2, right? Now we need to prove if n is equal to k plus 1, it's true. So what we need to prove, if n is equal to k plus 1, we need to take the equation k plus 1 into k plus 2 divided by 2, right? For n is equal to k plus 1, we need to get the equation k plus 1 into k plus 2 divided by 2. This is the equation we need to get for k plus 1. That is the thing we need to prove, right? To prove that one, we already get an assumption, right? So this is the assumption equation, right? So this, let's say I'm taking this equation 1. I need to use this assumption equation 1, right? 1 plus 2 plus 3 plus k is equal to k into k plus 1 by 2, right? This is the assumption. From this assumption, I need to take this equation, right? So how to take this equation? So both side of the equation 1, I am both side of the equation by 1, I am adding k plus 1, right? So if I add k plus 1 both side of the equation, now the right hand side is 1, 2, 3, k plus k plus 1, right? So my right side is now correct, right? In the left hand side, k into, sorry, this is k, right? This is k into k plus 1 by 2 is there. Now I need to add another k plus 1. So if I take the addition of the number both side of the equation, this equation is not changed, right? That is a common truth, right? So if you do any operations, you need to do both side of the equation, right? So now I add k plus 1 both side of the equation, right? Now what I need to do, I need to take 2 as a LCM for these two, right? 2 as a LCM for these. Give me a minute. Hello? Okay. Sorry for that. Okay. So in my, in my left hand side, k into k plus 1 by 2 plus k plus 1, right? From this one, I need to prove this, right? So how to take this one? So I take 2 as a LCM. So k into k plus 1 plus here, if I take 2, 2 into k plus 1, right? So now what will happen? If I take 2 as a common, right? K squared plus k, if I remove the bracket, plus 2k plus 2, right? k into k plus 1 by 2 plus k plus 1 I am adding. So k squared plus k. Then, sorry, here. K into k plus 1, 2k plus 2, right? Okay, now this one, right? So now what will happen? K squared plus 3k plus 2 over 2, right? So now I need to apply the quadratic equation. So I need to find out the factors, right? So k into k. So 1 into 2, 2. So 2k plus k. So the factors of this one is what? The factors of this equation is k plus 1 into k plus 2 in over 2, right? Now we can take this one, right? So k plus 1 into k plus 2 by 2, right? This is the equation we need to prove, right? So this is the mathematical induction, right? So whatever the equation you can prove by using the mathematical inductions, right? So why we are discussing in the set theory, while you are doing the mathematical inductions, definitely they will apply some set theories, right? So set theories in the sense maybe they are, sometimes they are giving, let's say, yeah, just look at here. This is the similar mathematical induction. Yeah. Uh, So, so if you look at here, right, this is why. So you need to remember while you are doing the mathematical induction, first you need to prove if n is equal to 1, then you need to prove it's true, right? You need to prove it's true, right? Then you need to take assumption if n is equal to k, then you need to take it's true. Then from the assumption you are taking as a true, then you need to prove if it is a k plus 1 that is true, you need to prove, right? This is the mathematical induction theory. You need to prove for 1, then take to n, then you need to prove to n plus 1, right? That is the normal things you need to do for mathematical inductions, right? Now just look at here. This is one example, right? The sum of first n odd numbers, 1 plus 3 plus 5 plus 7 plus the common form 2 to the power n minus 1. So the first n odd numbers, the sum of the first n odd numbers, we can say n squared, right? This is one common equation. So they are asking you to prove by using the mathematical induction. Then you can take it's true for n is equal to 1. Then you can take it's true for n is equal to k. Then you can prove k plus 1 it's true, right? This is the induction order. So while you are look at this type of induction questions, definitely they will mention, right, what is the n is, right? So they are mentioning, right, n is a set of positive integers or natural numbers, right? So on that time, you need to understand this is the set of n natural numbers. So whatever the mathematical induction, they are using set notation to indicate what are the values possible for the equation likewise. So you need to understand these set notation of numbers to do the mathematical inductions, right? So just imagine now in this scenario, right, they are mentioning as a n is equal to 135 likewise, right? So if I giving maybe x is equal to 135 or something, then if you take first number as a 1, the second number you need to take 3, right? Not 2 you need to take, right? You cannot take 2, then you need to take next element as a 3 likewise, right? So this is mathematical inductions. This is no need to worry about this mathematical induction. This is very basics. Uh, while you are doing mathematical inductions, definitely they will tell you some set notations. So from the set notation, you need to catch what they are mentioning. That is important, right? Yeah, that's all for the set theories, right? Yeah, it's for your easiness, right? Someone asked, we need to put brackets, curly braces while you are writing sets. It's up to your easiness, right? If you are putting a brackets, then you can easily separate the elements, right? That's why we are putting braces, right? Okay, now we will look at some questions, right? Okay, okay, today I will share the slides, right? Now from this slide onwards, continuously you have exercises, right? So as a homework, try to do these exercises, right? For all the topics what we are discussed here, they have some exercise, right? Try yourself, right? If you have any doubts, we will discuss, right? First, you can ask some of your friends. Maybe they are clear on these topics, right? If no one know in your batch, please let me know. I will explain those things, right? So these are the exercise questions, right? Also, they have answers. You don't need to worry about that one. They have answers as well, right? For all. Okay, I will explain one or two questions, right? Okay. Okay, the first questions, just look at here. Maybe definitely we have some question from these exercises for your final exam. So uh, just try to do, right? For maybe while you are physically come to the university, you have continuous assessment. So for that continuous assessment, I will take some question from these uh, exercise questions, right? So don't miss these. Try to do yourself as a homework, right? So up to now, what we are discussing set theory, it will cover throughout this question, right? So if you look at the first question, which of the following sets are equal? Just look at here. They are giving four different sets, right? They are asking which sets are equal. So what is the theory behind the equal sets? If two sets becomes a equal, their sets have same number of elements, as well as all the elements are same elements and same number of elements. Two things you need to satisfy, right? Same elements, same number of elements, right? If you look at this set, they have three elements x, y, z. What about this set? What about the second set? What do you think? The z element is duplicating, right? So if you have a set this way, you can rewrite this set as a this way, right? So how you can rewrite z, y, just you can omit the second set and x. So this is the set, right? If you look at this set here, y, x, second y you need to omit, then z, right? How about the last one? If you look at the last set, that one also duplicate y, z, x. So you can omit the last y. So if you look at all the four sets, all the four sets have how many elements? Three elements, three elements, three elements, three elements. All the sets have same three, not only three elements, all are same elements. So we can say all the sets are equal sets. So why we are doing here, even if you have a set with duplicating elements, you can say this is duplicating element. So you can remove this element. Then the remaining elements are the same element. So we can say these two are equal sets. Similarly, these two are equal. These two are equal, right? Did you understand the questions? The basic theory says we cannot duplicate the elements in the sets, right? So you need to remove the elements, right? Duplicating elements. Then you can check the number of elements and all the elements are equal or not. If the elements are equal and same number of elements, we can say they are equal sets, right? Now just look at here the second one. The list of elements of each set where n is a positive integers, right? So by using this set, they are telling n take the value of positive integers, right? Now they are giving some questions, right? Okay, A, B, C. Yeah, yeah. This question says list the elements of each set, right? So this condition, right? So you need to be careful about these conditions, right? So n always take the elements of positive integers, right? So we need to write the elements of A. Tell me what are the elements suitable for A. A is a set of X. Maybe they are not giving the detail set of. So now they are telling A is a set of X. X is an element of natural number, right? Positive integer, right? Such that so x between 3 and 4, greater than 3, less than 9. So what are the elements come? Tell me. not equal, 3 or equal, right? So starting from 4, 5, 6, 7, 8. These are the elements belongs to A, right? Similarly, if you look at B here, B is a set of X element of natural numbers, positive integers, such that X is even number and X less than 11, right? So if I starting from 0, is it correct? 0, 2, 4, 6, 8, 10. Is it correct? Is it correct? What do you think? Tell me the answer. It's wrong. Why? Already they are mentioned that the set n is a positive integer. So 0 is not a positive integer. Definitely you will start the numbers from 1, but 1 is not an even number. So you are starting from 2. So this is the correct set, right? So what about the third one? Third one, C is a set. Similarly, C is a set of X belongs to natural numbers, positive integers, and such that, so they are giving 4 plus X is equal to 3. So what is the possible value? 4 plus X is equal to 3. So X is equal to, what do you mean by 4 plus X is equal to 3? So X is equal to 3 minus 4. It means X is equal to minus 1. Can you tell me X take minus 1? Can't, right? Because N is a positive integer. So then what will happen? C is a empty set. Did you get my point? C don't have element. So that is an empty set. So negative, if negative value comes, we cannot say that's a set, right? That is an empty set. Why? Depending on this condition, right? So just look at here, no positive integer satisfy this equation. 4 plus X is equal to 3. So C is an empty set, right? So how about the third one? Okay. Here in the third question, 1.3, they are giving A is a set with elements of 2, 3, 4, 5, right? The first one, show that A is not a subset of this one. So they are asking you, right? So A is not a, so they are asking what we need to show. A is not a subset of B. So A is not a subset of B, right? A is not a subset of B, right? For that one, first we need to find out the B, right? So already we know the B, right? So B is what? So B is what? So they are explaining B. So from this explanation, you need to find out what is B. Right now, B is a set of X. X is a natural number. So positive integers such that X is even, right? So what are the values for X? Tell me. X is a natural number. X is even number. So 2, 4, 6, 8. And not this one. This is a infinite, right? So it will go dot, dot, dot line, right? So B is a set. Now B, you know B, right? So now consider, so this one we need to prove, right? A is not a subset of B. Right now we will find out the B. B 2, 4, 6, 8, dot, 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 right? That's an even number. Now, if you look at A have what is the different element here? 2 is there, 4 is there. So 3 and 5 is there, right? So how you can write the answer for this question, right? You can write 3 is an element of A, but 3 is not an element of B. Similarly, you can say 5 is an element of A, but 5 is not an element of B. So we cannot say all the elements of A not belongs to B. So we can say A is not a subset of B, right? This is how we can write the answer for this question, the first one, right? Sorry, the first one. Now they are telling that A is a proper subset of C. How to tell? A is a proper subset of C. What do you mean by proper subset? Tell me. Any volunteer to answer my question? So already we know A, right? A have 2, 3, 4, 5, right? Now they are giving a set C. So how you can prove to become a proper subset? Tell me how to prove proper subsets. So first of all, you can write the set C, right? So the set C is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, right? This is the set C, right? Now, what you need to do, each element of A belongs to, sorry, each element of A belongs to C, right? Right, so we can say A is a subset of C, right? First, you can say A is a subset of C, but you can say here there are some elements. One is not a subset of A. Similarly, the remaining elements, right? Yeah, the remaining elements is not a subset of A. So we can say A is not equal to C, right? So proper subset means not equal, right? So then we can say uh, A is a proper subset of C. If you don't remember, just go through the where we can discuss. Just revise the theories, right? So while you are practice with the questions, you can understand how to prove, right? So if you don't remember the proper subset concept, just look at here, right? Just look at here. You notice here what it says. The statement A subset of B does not includes the possibilities that A is equal to B. In fact, so what you need, how, if they ask to prove proper subset, you need to prove A is equal to B, right? A is a subset of B and A is not equal to B, then we can say A is a proper subset of B. Don't you remember those concepts? So if you revise these concepts on that question, right? If you don't know the answer, just revise the theory, right? To prove proper subset, first you need to prove as a subset, then you can say A is not equal to B, right? Then if A is not equal to B, then we can say that is a proper subset, right? So likewise, you can check with all the questions, right? So just look at here in the, yeah. So already we know the A, right? They are giving the C, then they are telling you A is a proper subset of C. So to show A is a proper subset of C, first you need to prove A is a subset of C. How you can prove A is a subset of C? All the elements of A belongs to C, then it's true. Then we can prove A is not equal to C. How to prove A is not equal to C? The element 1 is not an element of A. 1 is belongs to C. So 1 belongs to C, but 1 not belongs to A. Similarly, 5 belong, sorry, not 5. 6 belongs to C. 6 not belongs to A. So A is not equal to C. Then we can say A is a proper subset of C, right? Okay, now this is related to set operations, right? This is the last question I will explain. So as a homework, you can do all the things and please let me know by next class, or you can put if you have any confusion on any questions, right? So now they are giving a set U. So U is a set of 9 elements, 1, 2, 3 until 9, right? That is a universal set. U is a universal set with 9 elements. So they are giving A, B, C, D, E, F, right? Now they are asking first A union B. So A union B, how to write the A union B? So just consider A union B. You need to write all the elements of A and B. So 1, 2, 3, 4, 5, right? Comma. Then already 4 and 5 is there. No need to write again. Then you can write A union B, 6 and 7, right? Similarly, A intersection B, they are asking. A intersection B means the common elements between here A and B, 4 and 5, right? So you can write 4 comma 5 is the common element, right? Similarly, you can do the next one, A union C, A intersection C. Likewise, you can do, right? So as a homework, I will share the slides now, right? Do all the exercise